Hello students, in this video we'll see examples of rotating a function about the x-axis. Here is example number 1. Let's find the volume generated by rotating y equals 1 minus x squared, and let's say the portion above the x-axis about the x-axis. So we have over here, there's the x-axis, there's the y-axis. This function 1 minus x squared is a parabola that starts off at the point 1 when x is equal to 0 and goes down like this. So there's x equals 1, there's x equals negative 1. Those are the points where it crosses the x-axis, and when you plug in x equals 0, you get to the point 1. So we can imagine the geometric shape that occurs when we rotate this. We'll get a shape that looks like this. Draw the parabola, draw the under part of the parabola that we don't see yet, and then we have these circular cross sections. So we get a volume that looks like a football. Something like this. That'll be our volume in question. So that's our region. Okay? And we find the volume by the disk method. The volume by the disk method is the integral from -1 to 1. Those limits of integration will either be given to you in the problem, or you'll have to find them by a specified condition, namely the portion of the graph above the x-axis. So we integrate from -1 to 1. We need a factor of pi. Then we take our function and square it. The function is 1 minus x squared, quantity squared, dx. The rest is calculus. This will be pi, the integral from -1 to 1. We can notice that this function, we can make one sort of observation. This function 1 minus x squared, quantity squared, this function over here is even. So what I can do is I can write this as twice pi, the integral from 0 to 1 of 1 minus x squared squared dx. Make sure you understand this step that I said I changed the limits of integration from -1 to 1 to 0 to 1 because the function's even. Make sure you understand that step. Now, this is going to be a 2 pi, the integral from 0 to 1. Expand this out. This is going to be 1 minus 2x squared plus x to the 4th dx. So we'll have a 2 pi, and then we'll have a, when we integrate this, we'll get an integral, we'll get antiderivative of 1 is x. Then we'll have a minus 2/3 x cubed. Then we'll have a plus 1/5 x to the 5th from 0 to 1. So we'll have a 2 pi, and then we'll have a 1, a minus 2/3, and a plus 1/5. And when I plug in 0, I have nothing. So let's put everything in terms of 15ths. So this will be 2 pi, and then 15 over 15 minus 10 over 15 plus 3 over 15. And so that will be turned into an 8 over 15. So I'm going to have a 16 pi over 15 as my final answer. Let's see another example. Example number 2. Find the volume generated by y equals sine of x from 0 to pi. So I look at the graph of sine of x between x equals 0 and x equals pi. By rotating this function about the x-axis. Okay? So again, we're going to use the disk method. The volume, now, unlike the last problem, this problem gives us the limits of integration. It's between 0 and pi. I take my function and square it, dx. And we'll get a similar sort of shape. What we'll have over here is we look at the graph of sine of x. Sine of x looks like this between 0 and pi. And so we'll get a copy underneath here, and we'll get another sort of football looking region, like so. Now we use the power reduction formula. This is pi, the integral from 0 to pi, of 1 minus the cosine of 2x over 2 dx. That is power reduction, trig identity. You can verify this by the double angle formula for cosine. If you don't believe this formula, that's the power reduction formula. We use this quite frequently. And so now to the antiderivative, this will be pi. And then antiderivative of 1/2 is going to be x over 2. Antiderivative of negative cosine is going to be a negative sine of 2x over 4 from 0 to pi. Now, when I plug in either pi or 0 to sine, I'll have the sine of 2 pi. The sine of 2 pi is 0. The sine of 0 is 0. So these sine terms are going to cancel out. And so all that we'll have is we'll have pi over 2 and then 0 over 2. So all total, this will be pi times pi over 2. And this will just give me a pi squared over 2 as the volume of revolution rotating sine of x about the x-axis between the points 0 and pi. Thank you very much.